بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Thank you everyone for coming today to this very interesting presentation. And I'm delighted to welcome you all today in the seminar of Advances in Operational Artificial Intelligence, Trends and Challenges by the esteemed Professor Fakhri Karray. The seminar promises to be an engaging and informative event that will provide insights into the latest development of artificial intelligence. As many of you are already aware, Professor Karray is a renowned research chair professor in the Department of Electrical and Computer Engineering, holding the Loblaws Research Chair in Artificial Intelligence. In addition, he is the co-director of the University of Waterloo at the University of Waterloo Artificial Intelligence Institute. His research interests are centered around operational artificial intelligence, cognitive machines, natural human-machine interaction, and autonomous and intelligent systems. His research has led to significant breakthroughs in the development of cognitive and self-aware machines, robots, and vehicles, predictive analytics in supply chain management, and intelligent transportation systems. Professor Karray's impressive credentials extend beyond his research contributions. He is a fellow of the Canadian Academy of Engineering, a fellow of the IEEE. He has also been an IEEE distinguished lecturer, sharing his insights with audience around the world. We are honored to have him today here at Prince Sultan University to share his expertise with us. In conclusion, I want to thank you all for your attendance, and I'm confident that today's seminar will be a valuable and engaging experience. Thank you very much. And I give the talk to Professor Karray.
Thank you. السلام عليكم. شكرا أنيس. شكرا دكتور محمد للدعوة الكريمة وشكرا لرئيس الجامعة كذلك and everyone who has joined us today for this presentation. I wanted this presentation to tackle certain type of aspect of operational AI simply because we are living in a new era related to artificial intelligence, especially recently development in the field of generative AI, such as ChatGPT and DALL-E, and I will speak a little bit about that. There are many new developments in the field of AI, many operational AI type of applications. So I'm going to give a little bit of historic backgrounds on AI and the various themes of AI, and I will also give some of the research work that I have been doing in this particular field with my team, whether at the University of Waterloo or with Mohammed bin Zayed University. So this is a very brief affiliation of myself where I am now. So I am still Loblaws Research Chair of Artificial Intelligence. So I am on leave from University of Waterloo for a few years to help set up the new institutes and new University of Mohammed bin Zayed. I have been provost since 2021. I am now professor of machine learning at the same university, and I'm helping with the various programs at the university. I am also the founding co-director of the AI Institute at the University of Waterloo. Let me start with the very brief and very generic type of definitions on AI, which is the Encyclopedia of Oxford Living Dictionary. Defining AI. It is quite generic. Some of it is still true. Some of it is even a little bit archaic in certain regards, given that it doesn't include some of the major issues that have been developed over the past few years. This definition has been there, has been updated a few times, but is still, relevant to what we are speaking. So AI in general is the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. It's quite generic, it's quite general, and it can be applied to many types of fields. But as we are going to see, there are even more areas that this type of definition is not tackling. Let's look at various developments that have been witnessed over the past few months. Okay, so this is the most recent craze in AI, what we call craze. This is the generative AI tools. And generative AI tools, I'm going to speak in a few moments, is a new branch of AI. It has been developed over several years, but it has seen its peak over the past few months, and it continues to become one of the main pillars of AI. So if we look at what DALL-E, which is a generative system proposed by OpenAI, and everyone can utilize it, it generates it generates pictures of things that link to natural type of inquiries. I mean, you can see some of these type of examples. And as you can see in the second picture and the third picture, they are extremely natural type of pictures, as if they are real, but they are not real. They are concatenation of few items that the system has seen in the past and put them together so that they become almost type of realistic type of generated pictures. So this is, I mean, one of the major discoveries, and it has been made over the past several months for the general public. The second one, which is ChatGPT, and I gave a presentation in early December to a keynote to a conference in Abu Dhabi. And at the time, ChatGPT is not well known. It has only been there for few days, actually. And I have known about the ChatGPT coming along, I mean, for a number of months now, almost 4 to 5 months, although it was kept secret, I mean, in the research labs of OpenAI. And as you can, many of you are familiar with it. I'm not going to delve into it and what it can do. I'm sure that several of you have tested it and they were impressed with the capabilities, although it has a number of inaccuracies. It's not a perfect system by any means, but it's a system that has matured over several months, and it continues to be matured, and I will speak why it's going to become a very, very powerful type of engine in the next few months and few years, and there will be new generation of these type of interactive type of system. As you can see, it has the capability of being a descriptive system, a corrective system for coding, and even for statements that we provide the system and the system negate them, or it can be assertive with certain type of opinion. And this system, as I mentioned, has been developed by scientists at OpenAI, and I will speak a little bit about OpenAI in the next few moments. So this is what the CEO of cloud computing said on December 4th, 2022 about ChatGPT. He said, ChatGPT is one of those rare moments in technology where you see a glimmer of how everything is going to be different going forward. And when he said these statements, there are almost 20,000, 30,000 people who started testing with the system. And New York Times also, Kevin Rose, from New York Times, said ChatGPT is quite simply the best artificial intelligence chatbot ever released to the general public. So that was at the time in the early days of the ChatGPT, because these people were testing the system, and it was quite impressive. It is still very impressive system. Of course, it has a number of flaws, but it is a system that is being built and it is being improved by the company that has delivered it, and the number of people are currently using the API for the system to develop other type of engines and other type of products. So this is the outline, brief outline of what I am going to show here. So I'm going to speak briefly about the world landscape and the economic impact of what operational AI does. Overview on operational AI and machine learning, major impact of operational AI on society, and operational AI in the academic industrial context. And then I will conclude with a few remarks. And why I selected operational AI? Simply because it is the applied aspects of AI. AI is very, has many spectrum of theoretical type of tools, and operational AI is one of the applied elements of it, and where people are utilizing AI for the purpose of this particular components of AI systems. So if we look at AI machine learning landscape, and you can see the redder the area, the more it is active in that regards. This picture, I mean, this photograph is being changed almost on a daily basis. I mean, you see it from one month to the next, you see variation. It is very dynamic. So this one was taken several months ago from the website in Google, and it shows the activity on the TensorFlow usage by researchers in a particular type of area. The future is built by the fourth industrial revolution. So we consider that what is happening now with AI, the various type of spin-off innovations that are coming with the AI are going to utilize AI, big data, and machine learning as their main tool, as the fuel that is going to operate these type of elements of the fourth industrial revolution, which is going to see enabling type of technology such as intelligent robotics, nanotechnology, 5G, Internet of Things, computer vision, natural language processing, which we are going to talk about because it is related very much to generative AI. So all of those are breakthroughs that have been enabled by the field of AI, by the discovery of major algorithm in the field, and of course by the availability of digital type of data that are becoming available with huge amount of recent and future impact of AI on business, industry, and society is predicted to surpass the impact of the various industrial revolution combined. So this shows that AI is going to be an integral part of almost any type of business, any type of industry, any type of the society usage. And this is not small statements, because I mean, in the various components of the various revolutions that happened in the past, they started isolated. Only after several type of years, they start, I mean, catching up. But now we see it, I mean, it's only a few years, and almost many businesses from every corner of the economy are utilizing the tools of AI. The reason for the hugely growing role of AI is the tremendous opportunities for economic development. And we have seen only very small portion of it. So according to Deloitte and PricewaterhouseCoopers, GDP will set to grow globally by up to 14% by 2030. Almost $16 trillion. And the number of people are saying that this might grow even further than that, between the $30 to the $50 trillion contribution to the GDP because of the explosive growth of AI. This is unthinkable 5 to 6 years ago. No technology, no innovation has contributed to GDP compared to what the AI and its sisters, if we call it, or the various type of components of AI is doing to the industry. And all of you are seeing the impact of this AI. And this is a curve that shows, a diagram that shows the major components of AI in terms of the decision support, in terms of the agents, in terms of decision automation, the smart products, going from 2015 to 2025. And you can see the huge growth in the millions of dollars and the billions of dollars. So big data and AI machine learning are fueling huge growth in major innovative breakthrough in various fields. So this is becoming prevalent and almost in every type of industry. I mean, where you can gather a number of, certain amount of data utilizing AI machine learning. You can purchase, you can borrow, you can develop these type of data, and then with the tools and with the engines of AI and machine learning, you are able to develop any other type of enabling technologies, starting with smart robotics to material science to energy to smart grid to fintech. Almost every area of the economy is being touched by these major breakthroughs in the technology. Of course, the impact is affecting almost every industry and every aspect of the connected society. I mean, most of our society is connected not only in one country, but around the globe. Why this huge growth is happening? I mean, what is happening now? I mean, the huge growth in AI and its usage is due to a technological, what we call perfect storm. three major components are contributing to this. And this started, almost in 2010, 2011, with the exponential type of growth in this particular area. First of all, the powerful computing processors that are becoming available, not only for large institutions, but also for medium-sized, even for small companies. Huge storage facilities that you can rent, that you can utilize in academic institutions or in industrial type of setting. What we call the cloud computing, edge computing, which is another level of computing, which could be local to an institution, which could cooperate with cloud computing as well. The tremendous of data that is becoming available, and this data is in the form of text, in the form of images, in the form of videos. So it's becoming, huge, because we are able to store all this type of data and make them available to the masses. And then the third one is development of powerful and scalable algorithm. Very important component indeed. These type of algorithms have possibly some of them been developed 20, 25 years ago, but they have been refined over the years. And now we are seeing them being used in the various aspects of technology. One of them is deep learning systems. Deep learning has been discovered in the early 90s. But no one was using them. No one was even attempting to utilize them for a particular type of application because of the difficulty to gather the data or the difficulty to implement them in computer systems. Large portion of what we refer today as AI success are in fact deep learning breakthroughs. And I will define very, very briefly deep learning. Many of the colleagues here, I know that they are familiar with deep learning, but what we say AI nowadays mostly are breakthroughs in the field of deep learning systems. So we have to give credits to deep learning systems and to this type of architecture, and of course to the things that made them possible, to the breakthrough in cloud computing and the improvement of the algorithm and the storage type of capabilities. Only 10% of machine learning algorithms, however, that have been developed so far are being used in real-world application. 10% only of what we all develop, is being used, whether in institutions, academic institutions, whether in industrial institutions. This is very, very tiny amounts. And this needs to increase, and a lot of companies, a lot of academic institutions are trying to utilize this. And I have seen in my visit to some of the research labs here how these type of algorithms now are being utilized by developing some real-world systems, what we call operational AI. And I had the pleasure of visiting Professor Anis' lab, and I was very impressed with what they are doing there in the form of operational AI in the area of robotics, in the area of information retrieval, in the area of security. And I am very impressed with what our researchers are doing at this university, thanks to the leadership of the university. So there is a vast chasm between what we develop and what we are ending up using. And that's why I have been working on making operational AI one of the tools that a lot of people make use of. And that's the purpose of my presentation here. Let's look at very, very briefly the origin and history, because if we don't know the origin and the history of what is happening now, we might not progress to the next level and to the next innovation. So if you see the top left side, that's the early days of the sequential computing, which we call the computing systems. And von Neumann was one of the early pioneers in this field. In the 1940s, when he designed what we now see the architecture of the computer systems that we are utilizing, whether on desktop or laptop. This was discovered in the early days in the 1940s. And then the connectionist modeling started to appear as a parallel type of version to the sequential computing, the classical computing system, which we call it the connectionist models, the neural network. So the early days of the neural network, were started with Rosenblatt, with the help of McCullough and Pete and other pioneers in this field. So that was in 1950s and 1960s. So neural networks and the deep learning systems have their origin in these early days, in the 1955, 1956. At the same time, the conventional AI, which we call AI at the time, started in the 1955, 1956, where they were dreaming of developing algorithms that are powerful enough to mimic the human thinking, the human reasoning. But it was not very successful. I mean, over the next 20, 30 years, it hasn't materialized because we were utilizing rules, we were utilizing certain type of algorithms that are not capable of mimicking this type of behavior. And then the 1990s, the 2000s have seen developments of the early version of neural network, and then the deep learning systems that have been pioneered by Shmidoba, by Jeff Hinton, by people such as Yoshua Bengio and others who have pioneered these things. But despite their efforts, despite their work, these things haven't seen their real implementation in the real world because they were algorithms that cannot be implemented. The idea was there, but the implementation-wise was not there. And because of the capabilities of the computer systems were not there, we did not have a lot of data on which to train the system. But all of that has changed starting 2010, 2012, when a number of tests have started coming along with, in terms of minimization of the error performance systems for speech recognition, for translation systems, and using a new version of algorithms based on deep learning models. So this is a picture. I mean, the left-hand side of the picture, I took it, I mean, from the golden age of AI, Discover AI, and the right-hand side, I mean, I put it together. So you can see until 2000, 2010, 2020, so you can see in the upper part, major type of application, major part of implementation of this type of development. So you can see from 1940, the early days of the sequential computer till 2020, and now the present and the future, where we are seeing the power of large language model, LLM, or what we call also the generative type of system, such as the Chat GPT and DALL-E 2022. So those are major breakthroughs, and it took since 1940 to what we are seeing now, and we are seeing the major type of achievement in these particular fields. So in very concise definition here, of course, the AI is the effort to automate intellectual tasks normally performed by a human. So this is a description of what we mentioned earlier. Machine learning is an algorithm to discover data or presentation rules for prediction and classification. And deep learning is subsets of the machine learning type of developments, which involves hierarchical and multi-layered data type of representation. So AI is the supersets of machine learning, which in turn includes deep learning system. So that's how we define things to be, I mean, on the same ground for the definition. So this diagram that I have put here tackles the tools of AI. When we speak of tools of AI, the general type of tools. So we can see the upper one, the operational AI, which is the applied aspect of AI, which we see the generative type of AI, generate outputs, which generate outputs based on the data that they have been trained on. ChatGPT is one of the example. Foundational AI, which are the major algorithm that we are working, I mean, especially in the academic and research institutions, to develop, to improve them, and to make them viable for distributed type of computing, or for edge computing, or for cloud computing. And then the artificial general intelligence, which is the higher level of what we want to reach in AI, which is the highest level of utopia for, for having the AI system, operate. This is the foundational AI, so I won't go into the details for this picture, but it contains all components in the various field of AI: human-machine interaction, intelligent agents, game theory, optimization and decision-making systems, data science analytics, affective computing, and sentiment analysis. All of those, we consider them as foundational tools of artificial intelligence. Operational AI, they are systems that we are developing that are scalable, that are transparent, that are dependable, and we apply them to various type of areas of the economy or the industrial type of sectors. AI transforming the world, as I mentioned. So the light green means the artificial intelligence type of tools, and then you have the machine learning, the subset, the deep learning. And ironically, the deep learning now is contributing to the huge success of what we call AI. So the AI, the artificial intelligence, the conventional name of artificial intelligence is basically now successes of what we know as deep learning type of tools. Without going in the details, the machine learning, the various type of the machine learning type of systems. I mean, you go from supervised type of systems to unsupervised to reinforced to semi-supervised. And some of the systems that I'm going to speak in a few moments belong to any of those four major ones. So those are the four major tools, fundamentals of machine learning systems. So ChatGPT, for instance, uses unsupervised, it uses supervised, and it uses reinforcement learning to make it, as impressive as it is now. Deep learning at a glance. So again, this is very, very, concise type of diagram. So you have the machine learning, the usual tool of machine learning, and then the deep learning system. So in very, very concise type of description for those who are not familiar with deep learning systems, deep learning system provides us with a way to automate the feature extraction of a particular object. As simple as that. If you would like to come to the concise definition of deep learning, it has a certain number of layers that are extracting automatically the best possible feature of a particular system. So the features are not humanly extracted. So they are extracted automatically by a set of layers within the connectionist type of structure. That's what deep learning systems. And of course, later on, we can develop the various type of algorithm that provide us with the outputs that all of us want for a particular type of system that we develop. Deep learning architecture, there are, literally hundreds of deep learning architectures that are suited for a particular type of application. So this system is used for large scale image recognition. So this is what is known as the very deep convolutional neural network system. There is residual type of network, the ResNet and the ResNet-Com in various different type of architecture. ResNet 34 is one of the very, very good one that is used especially in the computer vision community. There is the deep learning architecture. The Inception network system is a very powerful type of system that has been discovered in 2014. And then we get to the transformers architecture, which is the backbone of what we call the ChatGPT system. So ChatGPT system is based on developments of various type of generation of transformers. Transformers is the latest type of technology developed in 2017 by researchers at DeepMind at Google, and they provide an excellent type of alternative to the usual type of neural network or convolution neural network and recurrent neural network. It has, in general, what is known as the attention mechanism, which makes it very, very powerful to run distributed type of NLP or computer vision type of tasks. And that is very, very powerful architecture. It has been used for NLP, it has been used for dynamic systems, for video recognition, for video reconstruction, and for many other type of applications, and of course, for generative type of AI systems. So if we look at the generative type of AI system, the best representative nowadays is the ChatGPT that many of you have tested, many of you are familiar with. It is simply a generative model based on major developments in new generation of deep learning model called transformers. So transformers are the new generation. And the generative pre-trained transformer, GPT, are generation of large language models that have started with the BERT system at Google, and then it went to the GPT, GPT-1, GPT-2, GPT-3, and now GPT 3.5, and soon to be released GPT-4. It's going to be released possibly in a few days from now. Very, very powerful systems and very large language models with major type of capabilities, and they are using also various type of learning mechanism, as I mentioned to you, the GPT system and the GPT 3.5, which is the more modified system that is using the human type of feedback system and using for reinforcement learning through the human feedback, is the core kernel of the ChatGPT system, and which a number of colleagues here are starting to use as their kernel for developing new type of technologies and new type of innovation, especially in the Arabic language system. So ChatGPT is a sibling model to Instruct GPT, which is GPT 3.5, which is trained to follow an instruction in a prompt and provide a detailed response. So that's the development, and that's what is the definition of this type of system. So it is large language model that has received a certain type of fine-tuning through feedback from human to improve its capabilities. And this capability is being improved every time one of us send feedback or comment to the ChatGPT website. So this is, it's a system that is being refined and being improved as we speak. And very, in the very near future, we are going to see the ChatGPT system, which is multimodal, a system that is going not only text, but is going to use pictures, is going to use also video systems. Microsoft is testing this particular model, and it's going to release the first set of system in the next few weeks. The general architecture of ChatGPT, so I'm not going to go over the details, but it is a pre-trained type of system that is using the transformer capability of deep learning models. It is being fine-tuned, and then the Instruct GPT system, which is fine-tuned by a human and also by supervised and reinforced type of learning system to give us the outcome of the ChatGPT system that we are using. So this system is dynamic in nature. It is being improved as we speak, and the number of changes are going to occur to it to improve its output and its capabilities. These type of technologies, as I mentioned earlier, they are transforming all major sectors of industries and businesses, and that's why operational AI is very relevant to the development of AI systems, because we are implementing them to the banking, to insurance industry, to transportation, to the grid system, smart cities, to education. Almost the healthcare model, almost every area is going to make use of this. And now I'm going to come later on to the few challenges that we are going to encounter in this particular area. Of course, the benefits to the society of operational artificial intelligence and machine learning are tremendous. Okay, so many innovative technologies have been built over the past 10, 12 years that are using the power of operational artificial intelligence, and namely certain type of architectures for deep learning system. Spin-off technology made it easier for consumers to increase the efficiency for our personal lives. Long-term gains in efficiency and productivity for small, medium, and large businesses is being observed right now. Transportation becoming safer. Cost of trade will diminish. A lot of benefits to the society, especially in the healthcare model. These operational AI systems, as applied to the various type of area of the economy, are tremendous. Sample research project in operational AI that I have been working over the past few years, and then I will make few comments on that. So I have worked on operational AI and of course on foundational AI. I have two teams, cooperating teams, especially at University of Waterloo, and now working with colleagues and with the students at Mohammed bin Zayed University on various projects related to operational AI in various fields. And why I'm mentioning these type of projects? Simply because I am cooperating and I am partnering with corporate partners who provide me with data. So most of these projects that I'm going to enumerate, they are projects for which I have used the data from partner institutions. or I have purchased them from companies that are selling this type of data. So I'm not going to talk about the theoretical components of the algorithms, but I'm going to describe some of the research projects I have been involved recently. So I start with the area of smart mobility or intelligent transportation systems. Connected vehicles are becoming, reality in various parts of the world. Driverless, autonomous cars, also there is major type of improvement in that particular direction. Smart highways and ADAS systems of the vehicles are becoming very prevalent, and it is the next generation of intelligent transportation systems, and they are making use of the power of AI and deep learning system and operational AI. This is one of the work that I have tackled with one of my PhD students and my postdoctoral fellows a few years ago, and it is coming with new algorithmic systems that is based on adaptive temperature conditioning type of rule system, where I have used what is known the integration of soft and hard sensing systems. And this is the first time that an algorithm has been utilized, applied to intelligent transportation system to provide a final decision on predicting the next stage of the next portion of the highway system, provided certain type of data in real time and from the past. And this, we applied it to a major part of the Bay Area in San Francisco, and we have utilized the data out from University of California, Berkeley, and also from the Transportation Board of San Francisco to develop these type of algorithms, which provided us with one of the best prediction available in the literature for this particular system. So this is a very dynamic system, and we were able to predict any portion of the highway system of San Francisco based on the few minutes before, and also on the past type of occurrences, and also on soft type of information from Twitter, where people send a Twitter about a particular location on the highway system. How we combine this type of information, soft and hard type of information, and the weather type of information, how we could combine all of them using the Dempster-Shafer theory for fusion of the feature type of system. And this work has received the Best Land Transportation Paper Award in 2021 because of the accuracy that we have reached compared with many other type of algorithms that have compared our results with the other type of algorithm. Another area that I have been also interested and have been doing some work is the virtual healthcare system, where we would like to minimize the time people go to clinics or to go to hospitals. And as much as possible, if we can provide them with the power of IoT, with intelligence system through edge computing and cloud computing, with the best possible type of advice within certain type of range of feeling or the status of particular patients. And if we are able to keep elderly or patient in their home for certain type of ailments, and using the major power of a virtual healthcare system, that would be big success. And I am cooperating with Cleveland Clinic in Abu Dhabi for designing this particular system, and we have applied it to activity descriptor, semantic activity descriptor for a number of behavior within a room. So you have people, elderly, who are living by themselves, and the system is able to detect all various type of stats of that person, from their blood pressure, the sugar level, to their behavior when they wake up from in the morning, when they are walking on the, climbing the stairs, or when walking around the thing. And we are able to create a semantic descriptor of that particular person and compare it with their current or the normal activities. And as soon as the system detects a certain type of abnormality, then it sends notification to various type of level. So we are testing this particular system for falls, when people fall, from their bed or from their chairs, and also when they are around confined environment in their own house. So we are testing the system with Cleveland Clinic, and hopefully if it is successful, we are going to test it in a number of patient locations there. So the technology there that we have developed, we developed 3 levels of fusion of the information at the sensor level, at the feature level, and at the decision level. And the good thing about that, we do it almost in real time using the edge computing capabilities and the cloud computing cooperation with this type of system. Operational AI in agriculture. I received major grants from Loblaws, which is providing me with a research chair on predicting the best places from which to pick the type of agriculture crops for various type of area, especially in California. And they asked us to predict from where to buy and from where to purchase the system 4 to 6 months prior to them buying them, because they are going to, before, they purchase the system, they have to buy it at least 2 to 3 months before. And if we can give them 2 months in advance before they purchase these type of crops, then they can negotiate the price, they can bid on the price. So the weather to yield prediction, and we received a huge amount of support from California, from Loblaws for this particular type of data, and we developed almost 25 models. And then we compared them with what has existed in the past and what the system provided us with the last year, and our prediction came to around 75 to 80% success in that particular area. And we are going to utilize now the same system for a project known as Malaria No More, where we are going to predict the location of certain type of area in Indonesia and in Central Africa, where we can predict the disease transmission of malaria related to the part related to climate, related to deforestation. So we would like to create predictive model. And if we say that this part will become next year a basis for transmission of malaria, then they go there and they inoculate the population in that particular region to prevent from the malaria disease in that regard. So this is we are going to use the same technology. Another operation AI type of example is to use the multi-human nerve system, which is to predict the behavior of people, a number of people within certain type of region, based on few sparse type of inputs that we gather either through video or through static type of camera. Why this is important? As you have heard about the metaverse, is to provide the best possible description of people or moving objects utilizing very sparse amounts of input data. Because a lot of input data, when you create them, when you fuse them, they cost a lot of money, they cost a lot of resources, computational type of resources. However, if we get sparse type of input type of data for those systems, and we are able to get the best possible type of description of the novel view synthesis of the system, that would be a very, very good success in the area of the metaverse or virtual reality system. And the technology utilized before, it's called the neural radiance field, and it has been used only for individual people. And we are applying it here for multiple people, and where there is certain type of occlusion. And we have used a set of deep neural network system, namely the ResNet34 and the sparse network system, to create view encoder and also the human encoder system, and fuse them according to a certain type of fusion algorithm, utilizing what is known as the cross attention. So this is also some of the work that we have compared with some of the best type of technologies existing in the area, namely the neural human performer. And as you can see on the left-hand side here, this is, the state-of-the-art type of technology. On the right-hand side, the black one, and this is what we have developed. So in the other one, you lose certain components of the system when it is occluded, and here we're able to have the system almost behaving perfectly, and we have applied this to a number of other applications. So now from sparse type of input you are getting from a system, from a video camera, you can create, the environment in 360, and you can create the dynamics as you see fit there. We have done a lot of other projects in pattern signal recognition, fingerprint, speech recognition, image recognition. We have done it throughout the years, and this all of it sponsored by partner companies. Okay, how to build capacity in the field of operational AI. So I'm not going to go a lot there, but this is an important component whenever I visit universities or institutions where I give talk. So they tell me how to build capacity in this particular area. So the first thing, especially for companies at the micro level, so anticipate the trend and strategize for any type of industrial type of entity. Build AI ML cluster centers with expertise in core areas of the business. Even if you don't have it now, try to build, kernel of these type of technologies. And I noticed this, here at Prince Sultan University, and I was very, very happy to hear the very successful experience by the faculty member in this regard. Build data storage, so whether you can purchase it, whether you can borrow it, or whether you can cooperate with other institutions. That is very, very important in that regard. Having a data storage system, that is very, very important for your research work. Increase the business leaders' knowledge of advanced analytics to create demand. So this is especially for corporates, the corporate world, and for industrial institutions. Build a high-performing team in the fields of AI and machine learning. Try to recruit, even at the early stage. Even if you haven't recruited in the past, try to create certain small units, and that unit could grow organically in the future to tackle data that you collect or to tackle systems that you haven't tackled in the past using the techniques of AI. Embed early on data and analytics in transformational and strategic initiatives. This is very important. You have to look, even if you don't have anything right now, try to strategize, on the short term, the mid-term, and the long term by getting resources, people, data in that particular field that will put you in competitive type of advantage. Course of action from macro perspective for the bigger course, government, public and private institutions have to invest now and big. And a lot of countries from around the world are doing just that. And I see that Saudi Arabia is one of the leaders in this field. UAE is also doing quite a bit of good job. Qatar is doing very good job in the Gulf region. And this is the right thing. Creating capacity, creating research centers in academic institutions such as what is happening here. Massively train students and professionals on the state-of-the-art tools of AI and ML. And that's what I saw yesterday during the tour of the lab of Anis. Enthusiasm of students, of researchers, developing the latest type of technologies, something that I haven't seen even in advanced institutions. The students here, very motivated. Researchers are very motivated to develop and to help. And I congratulate you, on this effort and the efforts of what you are trying to do by developing new masters in the various area of the AI system. So this is very, very encouraging, and you are responding to what needs to be done. Of course, the role of the university is fundamental in any of these type of things. The open AI system, the ChatGPT, wouldn't be there if it were not for cooperation with major institutions. Of course, they have a good number of research scientists, but they have also a number of research visitors coming to them from the major universities. They cooperate also with universities, especially Stanford University, University of California at Berkeley, are among the two universities close to the OpenAI headquarters that are cooperating on ChatGPT. They are cooperating with other universities, well known in the area of the transformer technology to develop these type of systems. Without that type of cooperation, the major breakthroughs wouldn't be there, because most of these type of tools, whether transformers, whether these type of advanced reinforced learning systems that have been developed by Carnegie Mellon University and other university in that field, the advanced one using the human feedback, various type of algorithms. If it were not for those people and the people that are utilizing them for the purpose of operational artificial intelligence, this type of breakthrough wouldn't be there. So the university has a major type of role to satisfy. AI research institutions' typical activities. I have been involved in two of them. Actually, I have been involved in the foundation of the AI Institute at the University of Waterloo, starting in 2017, where I have put together a number of faculty members, a number of research group, and now it has prospered, and we have a number of research projects supported by major companies in North America. So I am also, I have led the efforts from September 2021 till the end of 22 as a provost of Mohammed bin Zayed University by recruiting faculty members, recruiting top students from around the world to support these type of activities. So we provided workshops, we provided short courses with tutorials, short-term and long-term type of research projects, and we provided hackathons, and we sponsored a number of technical activities in these fields, and we also invited interns from various parts of the world to feed into these type of AI research institutions, because they are new things. And they are challenging to recruit good people, to recruit faculty members in these particular type of fields. And this is the role of AI research institutions. And I'm very happy to see there is great efforts at the university here to do just that. Challenges and risks, of course. I mean, all technologies, all innovations do not come without challenges. There are a lot of challenges, and the field only at its start. So larger businesses still have generally benefited from AI more than smaller companies. This is very true because they have a huge amount of funds. And as you can see in the early 2020, companies such as Microsoft, such as Facebook, such as Google, they kept recruiting people, I mean, at a very, very high cadence. Of course, that has backfired over the past few weeks and past few months, because a number of these people also, I mean, got fired because they tried to gobble up as many people as possible with a certain type of expertise. So if you are overdoing it, then it backfires on you. AI is still in its infancy. There are a number of thematics in AI that we haven't tackled yet. Major type of research work in the area of transformer systems, a lot of area with applications are still in their infancies. There is also the issue of trust in AI, fairness and bias in machine learning. And this is what the ChatGPT people have been doing over the past few months. So the ChatGPT 3.5, I mean, is the early version of the ChatGPT, and they tried to create, I mean, better improvement, fine-tuning of the system to make people trust the system when they are interacting with it. Trust in AI is very fundamental, and this is the fine-tuning that I have mentioned using the reinforcement learning through feedback of human with a certain type of reward type of function for that particular model. And this is very, very important for safety of the human AI interaction, because we don't want our children, our kids, or people to start interacting with the system and giving them bad information about things, bad things that we don't want them to do. So there is the trust in AI that we need to improve. The fairness and the bias in machine learning also is very, very fundamental, and this is something that we can keep growing. Or issues of catastrophic forgetting in continuing learning is also something that people have been working. So these are areas of research where people could also contribute in this particular type of area. More powerful algorithms that are transparent and explainable, implemented on adequate architecture and integrated with other tools of AI could get us closer to achieve more powerful operational AI. So if we integrate these type of tools that we feel that we are confident about their outputs, put them under different type of setup, computation type of setup, hybrid type of systems, test all of these type of technologies. Edge versus clouds, combination of edge and cloud could be type of architecture on which to implement this type of system, increase their transparencies and the explainability of the outputs of this type of system are also challenges and risks that needs to be tackled. Using deep reinforcement learning systems, similar to what we are doing with the GPT is system that being, researched by a number of companies from around the world. So these are open research areas that could also being utilized. I was speaking with one of our colleagues here about utilizing ChatGPT in Arabic and the good work, the excellent work that he's doing with his students and researchers to make ChatGPT becoming also versatile and powerful in the Arabic type of language. Utopia of AI, of course, we would like to use the human reasoning as a guide to build systems that provide better services or create better products. Excellent example, ChatGPT again. ChatGPT that you are seeing now, although it's not perfect, it has been also used the benefit of the human being, the powerful feedback of people using reinforcement learning through human feedback. So the human reasoning, the human output is always beneficial and always needed for delivering these type of systems that we would like them to be as trustworthy as possible. And of course, we don't want to utilize or create replica of the human minds. I don't think that we are able to do that at this particular stage, but by cooperating with the human minds to deliver something that is powerful enough to feed our curiosity or to be utilized in various areas of the society or the economic sectors would be very, very powerful. Use AI outstanding capabilities to enhance our world and benefit the well-being of the society. This is the ultimate goal that we would like to do. And this is what we call AI for social good. And I'm sure that you are familiar with it. As long as we are delivering these type of AI systems that benefit the society, that benefit the humanity, this is the ultimate goal of what we would like to utilize for AI and of course, operational AI. Finally, this is a textbook that has been released a few weeks ago, and it has almost all the algorithms that I have developed with my students and the postdoctoral fellows. And this is going to be also utilized at Mohammed bin Zayed and the University of Waterloo as the book of choice for courses in the area of element of dimensionality reduction and manifold learning. So it was published in early February, and the first author is one of my former students who has graduated 2 years ago, and we worked on this textbook for almost 4 years with colleague Mark Crowley, who's a professor at University of Waterloo, and Professor Ali Qudsi, who's also eminent professor in the area of statistic systems, and he has used it for machine learning models. So this book, you can find it on anyway, and for those of you who would like to use it for personal use, I will be happy to send you a link to have access digitally for this textbook. They provided me with the ability of sharing it with, very restricted focus of people. Finally, I would like to thank my colleagues and my former students and my current students for their help. Without their help, I wouldn't be able to present what I have presented now. So I'm very grateful for their support, for their hard work, and for their diligence. And a number of references, from some of my publications or other colleague publications I have used for this presentations. I haven't put all references in many of the pictures, many of the diagrams there. Okay, and with that, I end my presentation, and I will be happy to hear some of your feedback. Okay.
Thank you very much, Fakhri. It was a very informative and engaging presentation. We really enjoyed it.
Thank you.
And now we open the room for questions. Yes, Dr. Mahmoud is the Dean of College of Humanity and Science.
Oh, okay. Nice meeting you.
Thank you. Okay, Assalamu alaikum. For a non-IT person, I think it was sold. This is by far one of the most enjoyable presentations I've ever attended in the past couple of years. I think you managed to instill a feeling of excitement and, but yet with intimidation on what comes next out of AI. Are you at all worried about the social effect of AI as we go into the unknown? This is how I describe it, really the unknown. There is a race to advance in this field, and I cannot say that it's not business oriented maybe, but do you think that we should, so the first question is the social effect. Should we be worried about that at all? And then the second question that I have is that, do you think we should look at the priorities, maybe direct AI towards disease fighting? I mean, look at COVID. It caught us by surprise. I think the entire Earth failed to deal with it as we all wanted would have wanted to deal with it. Look at the recent earthquake. I mean, it proved that we are fragile, no matter how smart we are. Do you think we should prioritize? Thanks.
Yes, thank you. Very good questions, yeah. The first component, the social aspects of AI and its contribution to the society is becoming, unquestionable. It's going to penetrate every part. Our kids now are using the ChatGPT to deal with a number of questions, to deal with a number of challenges. So it's becoming versatile, it's becoming prevalent in everywhere. So we need to have AI, we need to embrace it as a society. How to embrace it? We need to embrace it in an ethical way. We need to embrace it in a very safe way. This is the challenge, how to do that. This is a problem that parents, instructors, academics need to develop these type of tools that need to benefit the society outright rather than causing a certain type of harm. But AI is going to become part of our everyday life. Yes, it is something that we need to accept, but we need to also prepare provisions on how to prevent all the negative type of things. And this needs discussion among parents, among colleges, among schools, even high schools, primary schools about this, and tell them, yeah, look, this is very beneficial, but you need to be careful. This could backfire on you, this could do a lot of damage. Concerning the second question, and I agree that there are a number of directions that we could go into AI, and it is, people are using AI for the benefits of healthcare. There are a lot of institutes from around the world that are using it, and even the technologies that have been developed, by Pfizer and by what is the other company? BioNTech, they have used AI, they have used data that they have gathered over the years to advance the vaccination type of outcome, because they found it within few months. Usually vaccination, takes years to do that. So many of the tests that have been made over, digital type of systems. And this has opened major area in the area of drug discovery and also in the area of protein folding type of systems. So I am aware of a number of companies that are doing this. So there is very, very good benefits in that regard, and this is only the tip of the iceberg, and we hope that we could encourage this type of development in that field. Thank you.
Any other questions? I have a question. Thank you, Fakhri. So we are seeing that AI is currently replacing us in many areas. Now AI is making predictions, AI is writing us text,
yes,
is able to see like humans, make classifications, make detection, make recognition. So what will be the role of human intelligence a few years later with respect to the artificial intelligence going into this invasive manner at a very high rate?
Yes.
So I expect by 2030 or 2050, what would be the role of human intelligence as compared to the artificial intelligence that we are driving by our human brains?
Yeah, the human intelligence has the power of driving the intelligence of these systems. That's how I see it. So human is always, when we are learning about ChatGPT, those are people who have spent years in the work of the ChatGPT system and the various type of components. So they are the intelligent people behind these type of systems. Now they introduce to us this particular system. Now the intelligent human is going to make use of this type of system to benefit the society if you would like to do that. And the number of applications, number of startups have already started doing it. And some people, I mean, even doctors are starting to develop the ChatGPT for diagnosis of disease. So they are going to feed the kernel of the ChatGPT for their own purposes. So the human is always, I see it, is the more intelligent, the higher level of intelligence that make use of this type of system. So ChatGPT becomes the quote-unquote digital slave of the human. Okay, so it's not going to surpass our intelligence. Of course, systems could create issues, and that's the ethics components of developing the intelligent systems. Those people that develop these systems, I mean, they should be very, very careful about the nefast effect of these type of system. And that's why they knew ChatGPT system, when they started testing it in July of 2022, the system started, I mean, degenerating, really. I mean, saying something, I mean, bad, and then making discussion in very, very bad tone, in very, and yes, exactly. Yes, exactly. Hallucinating. And the system started to become, I mean, out of the scope. And next time, I'm going to do something for you. You develop me. So then the human intervened. The human intervened and knew that these type of outputs might become in the future, possibly not on text, but it could be applied on robots. So now what are we going to do? Okay, ChatGPT, yeah, wait, we are going to do something for you. So they took the kernel system, which is the GPT-3, and they started tuning it. To the fact that a human, the sane human, the standard human doesn't feel threatened or anything. So they created these type of filters through the reinforcement learning systems, through the human feedback. And they started improving the model during the past 6 months, and they haven't released it before they did that. So you can see that the impact of human is always there, has to be there, and we need to control this type of technology.
Yeah, and there is another very big challenge and big problem we have also with us, Dr. Salman, who is our IP specialist. Now, are we going to talk story about intellectual property with the rise of generative models? Generative models are able to generate any kind of things. They are able to generate text, they are able to generate pictures, they are able to generate books now, and I've seen some videos, some people are making business from ChatGPT and other generative tools like Midjourney for image generations. They are able to create a complete booklet for kids just from ChatGPT and Midjourney. Then they put it on Amazon store and they will get money. What intellectual property is here?
Very good question. I don't have perfect question on that, but the ChatGPT system has been trained mostly on publicly available type of resources. So Wikipedia is one of the major resources, and they have taken many of the textbooks from which they have received the approval for that one. So that's one particular type of thing. And of course from the internet, which is publicly available, and many of it, but internet provides inaccurate things for people. For the generative type of art, it has been mentioned, I think, that the people that have created this system, they don't own the IP. So if you generate a picture of a dog with another dog, similar to the furry friends of the system, so no one has intellectual property for that one. This is what I know about the DALL-E 2 systems and the generative type of system. But there will be rules possibly in the future.
Assalamu alaikum. Thank you very much for this presentation. I have a question about how can we protect data when we're running AI system. For example, we work in field of the salination of water. Business owner and plant factories owner need to segregate their data. How can we secure it?
Yeah, this is a big issue in the area of data protection. So, because a number of companies, they have a lot of data, and they don't have a lot of scientists who do, analysis of this type of data or predictive type of analytics for this type of data. And this is an issue. So I have seen it in the area of medical systems. where authorities in hospitals, in clinics provided data to the governments, and the governments contract scientists to do these type of things. So there are some agreements for these very, these very safe data. You cannot play with it. And some of them provide them under certain type of server, under type of agreements. So they really put very tight things on the usage of this type of data. And the other part, a number of this type of data, if they are, so if you are a scientist, you are going to utilize the data, so you sign an agreement that this data is being provided to me. As soon as you utilize it in another type of software, the data, becomes completely noisy, so it's not structured at all. So when you do the agreement, you tell it that I'm going to utilize it, I am the person responsible, and it's going to be utilized on this software located in this particular component, and you can look at it. So there are a number of provisions that you can do to protect your data. But whatever you do, a lot of the times, data is being stolen. So everything that you do, and that's what many companies try to do. Yeah.
Thank you.
Other questions?
Assalamu alaikum. Thank you very much for this nice presentation.
Thank you.
My main concern is when I look at the last 2 years, all the main achievements or breakthroughs in deep learning, which is AI, cosmos,
Yes.
is by industry, not by academia. Did you notice that trend, which is very scary? It's really, last month I attended a presentation by Stanford professor, by the way, and you know that for sure, NLP Stanford is one of the best things.
Yes.
But now they become silent for the last 5 years. Stanford NLP is almost like...
Yes and no, very good observation. And short answer for that, a lot of these people, top scientists, have been recruited as either advisors or consultants to these companies because they have a lot of money, and the research lab, so they pay them very, very good money. Some of them have even left their universities outright. So these people that used to have 20, 30 PhD students and postdoc no longer have those things because they are working at these top places that pay them 5 to 6 times their own salary. So this is one major thing, but still there are a lot of research. There is quite a bit of research work, and some of it sometimes take a number of years before being marketed, before becoming a major component. And if it makes it, if you have an IP or whatever, then the company immediately recruits you or recruits your students.
Or by you.
Or by you, exactly. Yes.
I think Stanford, they're trying to recover. Today I mentioned to you in one of the posts that they are, Stanford are releasing today or yesterday their open source LLM model that is competing with ChatGPT.
Is that right?
Yeah. I didn't investigate this, but it seems, but they say it's only for education and research purposes, not for commercial purposes.
But what he mentioned actually supports the fear and the concern that it's business oriented and it's going to continue that way.
That's very true. That's very true. And business, because they have money, and money attracts. Money attracts the brains.
They got to control the direction where.
That's very true.
And that's lovely. If you see the latest trend in AI, it's no longer driven by universities. It's driven by big tech companies.
Yes.
It's
because there is money. There is generation
and we don't have the resources.
Funding. So one of the please.
Complete power.
Yes, one of the other things that I noticed as well is that government that used to fund, or even government used to fund, make big funding, are really stingy. They are no longer doing that, especially in North America and Europe. So they are not doing the payments. So they say companies, go ahead and do it. And the government used to do it. And the complication also comes from the fact why government used to do it. Most government used to do it in the military. A number of scientists in the field of AI do not want to get funding from the military. This is also another fact. It's very, very complicated.
It's amazing. Prof. Saminsky, I think last month I saw one of his last talk before he passed away.
Yes.
He mentioned that there is a shift in the Department of Defense, especially the Navy. They say they don't like AI.
Look at that. Interesting.
That's why there's a big move from U.S. Government funding.
Look at that. Interesting. I didn't know that.
Thank you, Professor, for a nice presentation.
Thank you.
My question is, we all agree how AI is powerful and especially these days after ChatGPT is released. But how can we control these powerful technologies? So now we are seeing students using ChatGPT to do homework, and researchers are writing books, writing paper. Yes, we agree that it makes making our life easier, but won't that affect intelligence of people?
Yeah, there are a lot of questions, I mean, similar to this one, because this is a monster that has opened its door, and we don't know how to tackle it. It's very difficult and very complex, yeah, to tackle these things. So the same thing that has brought people to discover these major engines, they have to sit down and they have to discover how to make sure that these engines are used in the right way. I don't mind ChatGPT being used as a tool to support, to a certain level, the write-up of a report or the write-up of certain type of components of that report. But writing the full system, the full paper or the full thing is becoming very, very dangerous, and there should be certain type of provision to prevent that particular aspect. But how to use it, I mean, this is new. So we don't have a lot of ideas on how to tackle these particular problems. Yeah.
Thank you.
Okay, I think we come to the end of the seminar. Again, thank you very much, Professor Fakhri, for the excellent and engaging discussion and the presentation as well. And we are very pleased and honored to have you at Waterloo University, and we look forward to further collaboration and further visits as well. Thank you very much, and thank you for all the audience.